Have you ever wondered how atoms in a molecule are arranged and how their electrons are shared? In this video, we'll learn how to draw Lewis structures, the essential tool for visualizing molecules and predicting chemical behavior. We'll go step by step and work through three specific examples: nitrogen trifluoride, formaldehyde, and the nitronium ion. By the end, you'll be able to draw these structures confidently and understand the rules behind them. The first step in drawing any Lewis structure is to determine the total number of valence electrons for the molecule. Valence electrons are the outermost electrons of an atom, and they're the ones that participate in bonding. For main group elements, the group number on the periodic table tells us how many valence electrons each atom has. For example, carbon is in group 14, so it has 4 valence electrons. Nitrogen is in group 15, giving it 5 valence electrons. Oxygen is in group 16, contributing 6 valence electrons. Fluorine is in group 17, giving 7 valence electrons. Hydrogen is in group 1, contributing 1 valence electron. Once we know the valence electrons for each atom, we simply add them up. And if we're dealing with an ion, we also need to adjust for the charge, adding an electron for a negative charge or subtracting one for a positive charge. Knowing the total number of valence electrons is critical because it tells us exactly how many electrons we have to place in the Lewis structure. Every bond and lone pair we draw will come from this total. Now that we know how to count electrons, we're ready to put this into practice with our first example, nitrogen trifluoride. First, we count the total valence electrons. Nitrogen is in group 15, so it contributes 5 electrons. Each fluorine atom is in group 17, contributing 7 electrons. And since we have 3 fluorines, that's 21 electrons from the fluorines. Adding them together gives us 26 valence electrons in total. This is the exact number we need to represent in our final Lewis structure. Next, we identify the central atom. Usually, the least electronegative atom, excluding hydrogen, goes in the center. Here, nitrogen is less electronegative than fluorine, so it will be the central atom. Now we connect the atoms with single bonds. We draw one bond from nitrogen to each fluorine. Each bond uses 2 electrons, so with 3 bonds drawn, we've used 6 electrons. That leaves 20 electrons still to be placed. We now distribute the remaining electrons to satisfy the octet rule. We start with the terminal atoms, the fluorines. Each fluorine needs 8 electrons in total, and it's already sharing 2 with nitrogen. So we add 6 electrons to each fluorine as 3 lone pairs. This uses 18 electrons, leaving 2 electrons remaining. Finally, we place these remaining 2 electrons on the central nitrogen as a lone pair. Now, if we check the octets, each fluorine has 8 electrons, and nitrogen has 3 bonding pairs plus 1 lone pair, completing its octet as well. And that's it. Our Lewis structure for NF₃ is complete. Now let's apply the same steps to formaldehyde. First, identify the total number of valence electrons available. Carbon has 4 valence electrons, oxygen has 6, and each hydrogen has 1. Since there are 2 hydrogens, we add everything up: 4 from carbon, 6 from oxygen, and 2 from hydrogen, giving us a total of 12 valence electrons to distribute. Next, we choose the central atom. Carbon goes in the center because it forms the most bonds. Oxygen is placed next to carbon, and the two hydrogens attach on the other side. With the skeleton structure in place, we begin forming bonds. Each single bond uses 2 electrons, forming 3 single bonds, 1 between carbon and oxygen, and 2 between carbon and hydrogen, uses a total of 6 electrons. That leaves us with 6 electrons still to place. We then complete the octet for the terminal atom that needs it. Oxygen requires an octet, so we place the remaining 6 electrons around oxygen as lone pairs. At this point, oxygen has 8 electrons, carbon has 6, and both hydrogens have 2, which satisfies their duet rule. However, carbon doesn't yet have a full octet. To fix this, we convert one of oxygen's lone pairs into a bonding pair, forming a double bond between carbon and oxygen. With this final adjustment, carbon now has 8 electrons, oxygen also has 8, and both hydrogens remain satisfied with 2. This gives us the correct Lewis structure for formaldehyde: carbon double bonded to oxygen and carbon single bonded to 2 hydrogens. For the nitronium ion, we start again by determining the total number of valence electrons. Nitrogen is in group 15 of the periodic table, so it contributes 5 valence electrons. Each oxygen atom is in group 16, so each one contributes 6. That gives us 5 from nitrogen and 12 from the 2 oxygens, for a subtotal of 17. Because we are dealing with a positively charged ion, we subtract 1 electron, bringing us to 16 valence electrons available for the structure. Next, we select the central atom. Nitrogen will be placed in the center because it tends to form more bonds than oxygen. The 2 oxygen atoms are arranged around nitrogen, forming a linear skeleton. With the skeleton set, we begin placing electrons to form bonds. We start by forming single bonds between nitrogen and each oxygen. These 2 single bonds use a total of 4 electrons, leaving 12 electrons remaining. We then move to complete the octets for the terminal oxygen atoms. Each oxygen needs 8 electrons to satisfy the octet rule. They each already have 2 from the single bond, so we distribute 6 more electrons around each one as lone pairs. Completing both oxygens in this way uses up all 12 remaining electrons. At this stage, both oxygens have complete octets, but nitrogen only has 4 electrons from the 2 single bonds, which is not enough to satisfy its octet. To correct this, we convert lone pairs on each oxygen into bonding pairs with nitrogen. This forms 2 double bonds, giving nitrogen a total of 8 electrons and forming a structure where nitrogen is double bonded to both oxygens. Because the molecule carries a positive charge, we indicate the overall charge of +1 on the ion. The final Lewis structure for the nitronium ion is linear, with nitrogen in the center, double bonded to 2 oxygens, and the whole species carrying a positive charge. And that's it for today's lesson on drawing Lewis structures. If something wasn't clear, or if you're curious about other examples, feel free to leave your questions in the comments. You can also suggest molecules, ions, or topics you'd like to see in future videos. If this lesson helped you, consider liking or subscribing. Thanks for watching, and see you next time.